Welcome back, Physical Science 20. This is the 11.3 booklet, Moles of Compounds, representing pages 320 to 327 of the textbook. And what we'll be looking at here is recognize the mole relationships shown by chemical formulas, calculate the molar mass of a compound. We kind of did that in 11.2, but we'll look at more complicated compounds, and calculate the number of moles of a compound from a given mass of the compound and the mass of the compound from a given number of moles, etc., etc. So if you look here, describe how many individual atoms, C, Cl, and F, there are in one mole of these. So if I just have one of these CCl2, F2, you can see I have one carbon, two chlorides, two fluorines. So if I had 1 mole of this, I'd have 1 mole of carbon, 2 moles of chlorine, and 2 moles of fluorines. Okay, so just like if I said I had a dozen of these, I'd have 1 dozen carbon, 2 dozen chlorine, 2 dozen fluorine. Okay, so don't get don't freak out because of the word mole being used. And of course, hopefully you have this down. Excuse me. I didn't put in the liter conversion here. I just simply left it with this. So hopefully you can get that down. And then looking here, so looking at pages 20 to 24 from page 321, we're hopefully going to squeeze those in here. First question is, how many moles of chloride ions are there in 2.5 moles of this zinc chloride? So you can see here, for every 1 zinc chloride, there are 2 chlorides. So for 1 mole of these, I have 2 moles of chlorides. So you can see the relationship there. 1 mole of zinc chloride has 2 moles of of chloride ions. So going from 2 moles of zinc chloride to however many moles of chlorides, you can see I set this up like this so that I can cancel moles of zinc chloride, moles of zinc chloride, moles of chloride ions. So 5. So 1 to 2 ratio, therefore if I have 2.5 moles, I have double the amount of ions. Moles of each atom in 1.25 moles of C6H12O6. So you can see in 1 mole of that I have 6 moles of carbon, 12 moles of H, 6 moles of O. Nothing too crazy or wild there. So I think I forgot to do O there. You get the general idea though after doing carbon and hydrogen. So starting off with 1.25 moles of the whole compound, of the whole molecule, and of course 1 mole has 6 moles of carbon, or 1 mole has 12 moles of H. So you can see the answers there: 7.5 moles of carbon, 15 moles of H, and since I have 6 moles of O, 6 moles of carbon, I'll have 7.5 moles of oxygen as well, because it's the same. How many moles of sulfate ions in 3.0 moles of iron 3 sulfate? So you can see in 1 iron sulfate, I have 3 moles of sulfate. So for every 1 mole of iron 3 sulfate, I have 3 moles of sulfate. So that is the conversion there. A total of 9 moles of sulfate ions there. And lastly, how many moles of oxygen in 5 moles of P2O5? So you can see the conversion there. 1 mole of P2O5 has 5 moles of oxygen. There it is right there. So 5 moles of P2O5 would have 25 moles of oxygen. And I think this is the last one. How many moles of H in 11.5 moles of water? H2O. Of course, you know 1 mole of H2O would have 2 moles of hydrogen. 2 to 1 ratio. So 11.5 moles of water corresponds to 23.0 moles of H. Fairly straightforward there. Now molar mass. Think of it as like a backpack. The total mass is equal to the mass of the backpack plus the contents. Now the textbook has a kind of a more complicated way of doing it. I have an easy way, just simply looking at the molar mass. If we have 1 mole of this, we have 1 mole of sodium, 1 mole of O, 1 mole of H. And I set it up very simple, as opposed to putting the mole conversions like we saw on the previous page. 1 sodium, 1 oxygen, 1 hydrogen. So if you look up sodium, it's 23. Look up oxygen, it's 16. Look up hydrogen, it's 1. So 40.0 grams per mole. And the part I left out there was just saying that, okay, molar mass is how much I have in 1 mole of this. And as we saw those conversions on the previous page, 1 mole would have 1 mole of sodium, 1 mole of O, 1 mole of H. That's what these ones represent. I just didn't put the units because I didn't want to overclutter the diagram. Calcium chloride, for every 1, so if I'm looking for the molar mass of calcium chloride, I'm looking for what 1 mole would be. So you can see I have 1 mole of calcium, 2 moles of chloride. Then from the periodic table, there are their respective masses. So 40.1 plus 71.0, 111.1. Looking at this one, here we have ammonium phosphate. Now for every 1 mole of ammonium phosphate, if we break this down, I need 3 ammoniums. So what that means is I have 3 nitrogens and 3 sets of 4 hydrogens, which is a total of 12 hydrogens. And of course I have 1 phosphorus and 4 moles of oxygen. So you can see the subscript pertains to what is immediately before it. If it's a set of brackets, everything in the brackets is applied. Or if it's just 1 element, it's just that 1 element. So nitrogen's mass 14, hydrogen is 1, phosphorus is 31, oxygen 16. So fairly straightforward there. 42 plus 12 plus 31 plus 64, 149.0 grams per mole. Okay, and now knowing that, we can do our regular conversions like we did in the previous booklet. So so these are questions 27 and 29 from page 323. So converting 3.25 moles into grams, moles into grams, moles into grams. So of course I have to multiply by the molar mass. So these are really the same, except the other booklet we just dealt with single elements. Here we're dealing with compounds here, so we have to figure out the molar mass off to the side. So as you can see here, I did that right here. So H2SO4, for every 1 mole of H2SO4, I have 2 moles of H, 1 mole of S, 4 moles of oxygen, so 98.1 grams per mole. So going from moles to grams, 1 mole to grams, at 98.1 grams per mole there. You can see moles cancel, and I'm left with G's. 318.825 grams. And of course this number is 3 sig figs, so 1, 2, 3. This is an 8, so this gets bumped up to 9. Okay, fairly straightforward there. We just have this molar mass issue here. That's the only thing that's new here. 4.35 times 10 to the minus 2 moles of zinc chloride into grams. Very similar calculation. Maybe pause the video and see if you can do the next 2 questions, and then turn the video back on, see if you got the right answer. Okay, if you had a chance to do that, first of all we have to figure out the molar mass of zinc chloride. 1 mole of zinc, 65.4. 2 moles of chloride, 2 times 35.5, so you get 136.4 grams per mole. And yeah, we need moles on the bottom, grams on the top, so our molar mass, we represent it like this, just like on the Y chart. 5.93 grams of zinc chloride. Next one, potassium permanganate, 2.55 KMnO4. So first of all, KMnO4, 1 potassium, 2 manganese, 4 oxygen, 158 grams per mole. Very similar to the previous questions there. So grams on top, moles on the bottom, etc. Okay, I think what we'll do is we'll stop there. Part 2, we'll look at the next part here, mass to moles, kind of working in the reverse direction. Okay, so we see you soon.